Hello and welcome to this episode of T-Tech. On today's episode, we're going to discuss VPN Basics. I do hope you enjoy this one, and let's get into it. Hello and welcome to this episode of T-Tech. On today's episode, we're going to talk about VPN Basics. So, we have three main types. We have an IPsec VPN, which that's a type of VPN that is built in to your operating system. So it's more portable to, have on every system, more widely supported. An SSL VPN is in the form of a program you download and install on your operating system. So like Cisco AnyConnect or OpenVPN, those are examples. So that doesn't mean you'd have to set it up on each computer you want to use it on. Now, DMVPN is actually more seen in cases where you need dynamic VPN connections to come up, but that it does utilize IPsec, among others, to be able to make the connections. But the main thing we're focusing on is what a VPN provides for us and why we want to use one. That's the main focus. Well, normally, without a VPN, we have our client, and that's our computer. And the red is representing the network we are connecting through. Okay? So this is, anything, a coffee shop, a hotel, etc. The idea is when we send packets without a VPN, we're sending them directly over the network we're connecting to. And when we connect to the server, like, for instance, if you look up in your web browser right now, and you'll see HTTPS, that gives you encryption and it gives you confidentiality and integrity. So you're talking to Google, and you're that no one in the middle can see the information. So like Bob here wouldn't be able to see it. But the problem is this. Even though you see HTTPS, you can have things happen where you can be tricked into not really connecting securely, okay? That's all we're going to say about that. But this is why we add a VPN as another layer of protection on top of this to avoid problems like this. So with a VPN, the whole point to understand is when you make the VPN connection, whether it's an IPsec VPN or an SSL VPN, you make the connection from the network you're on to the VPN server. This could be on the internet. You could use something like Untangle or pfSense, etc., to create a VPN server on your home network so you could connect back to that and have these advantages. But the thing that can get hard to understand is in that VPN tunnel inside of here, the IP addresses and everything at layer 3, the IP addresses and layer 2 information and all of that, you're still using this untrusted network represented by the red. So with a VPN, even if you're in a coffee shop or McDonald's, whatever, you're still having to use their network to get the packets to the server over the internet. But the difference is, inside of this tunnel, logically, you have encryption, you have integrity, and you actually have another layer 3 network. So that's the interesting thing about VPNs. It's a virtual private network. It's private because we have encryption and integrity, and it's virtual because it is laying on top of a real network. Now there's two more advantages. You can use a VPN as a proxy. Okay, that's the first one. That means instead of the network's IP address you're on being sent to the server and the server seeing that IP address, it would see the VPN server's IP address. But also, when you connect in to whatever network, if it's at your home or your business, you can see all the resources in that network if you configure the VPN server in that way. Okay? What I mean is, when you use the VPN, you can connect to things like your printers at home just like you were on the same network as those devices. Okay, that's why it's got the virtual network in there. I hope that made sense, but I'm going to put links for this stuff at the end. Now, the main thing that we need to understand with this is the port numbers they use. It's very important to understand these because when you get into firewalling and stuff like that, or if you're looking at Wireshark or getting curious, you'll want to know these things. So again, with those three types of VPN connections, the IPsec type uses UDP. Most all of them use UDP. That means they're connectionless, so you have lower latency, but if it is a better type of connection, but that is besides the point. The port numbers we want to use for IPsec are 4500, and that is for NAT traversal, and you want to use UDP 500. UDP 500 is for the key exchange and management. So what would take place over this is our exchanging public and private keys and our certs for identifying ourselves, or maybe our username and password, the authentication parts, encryption and integrity, that takes place over this port with IPsec. So if you're using IPsec and it's not working, you need to make sure you're not blocking those ports, okay? Because otherwise the connection can't be established. Now, SSL, the popular OpenVPN software uses UDP port 1194 by default. So that's the port that one uses, and again, it needs to be opened. But the idea with the certificates for the encryption, the public-private keys, and all of that, and the ways we can authenticate ourselves are the same. You can use it in a lot of different ways to achieve authentication. You can also use TCP port 443 or UDP port 443 if you're in enterprise networks where those may be blocked. Well, for 443 is less likely to be blocked, so that's why we would want to use that. And the dynamic multi-point VPNs, they use the IPsec ports and also can use other protocols. But the idea is it's for dynamic connections, like between a branch office to the cloud or a branch office to HQ, where you want to connect and access resources securely. Let's say we're at a store in the mall or whatever, or Amazon, etc. We make a purchase, but the thing is, when we make the purchase, it needs a way to encrypt. So that branch office's VPN would go out and make the encrypted connection to those resources. But just to kind of give you an idea of why dynamic multi-point VPNs are important, we might need to connect to multiple destinations securely. So we got to set them up on demand. Just to give you a little bit of an idea of these, why we use these. But it is more of a hybrid protocol, though. All right, lastly is the types of connections with VPNs. So you'll be able to understand most of what this is very similar to what we just talked about. But the idea is you can have site-to-site VPNs or remote-to-site. Now, with site-to-site, that is actually connecting two networks. So two network firewalls or routers, etc., together. So when you make this connection, you can actually use that as a WAN connection. So this would be a cheaper alternative to have a secure internet connection versus something like a T1 or a dedicated circuit like we used to do. Still around, but not as prevalent as it once was. But the idea is you still have client and server, though, is what I want you to understand. It's just the type of equipment we implement it on that makes it a site-to-site, because it's network to network. Okay. Now, remote to site, and by the way, the client in this case would be the branch office, like we talked about, and the server would be the edge of like the data center or whatever, or the other HQ, etc. The remote to site option is if you have to work from home, etc., and get access to resources. Well, to do that, you would use the remote to site, also called a road warrior connection. And you can set that up with OpenVPN or with IPsec, but the idea is it's one user's machine that is getting the VPN connection, not an entire network. That's the main difference. But to bring all this into perspective, I'm going to show a little demo of me using my VPN, and hopefully it'll make things a little more clear than just me talking about it. But with all that, I will see you in 1 second for that. And okay, so this is the lab here. Well, not the lab, actually. This was me using my VPN at a hotel. And I had to have an encrypted communication because, honestly, I don't ever feel comfortable just using wide open networks. I mean, you gotta remember, even if they have a password on the Wi-Fi, that's only for authentication. Once you're on, you can decrypt everything in that network. But you want to protect yourself. But anyway, this is without the VPN. I'm going straight through. There is actually, let's pause this, a few things I want you to take note of. One is the end of the IP, all right, and the time, all right. Those will be important after we connect to the VPN. So you can see the difference of the effect the VPN has. And this is the trace route. The tracer, rather, is on Windows, but this is the path it's taking through the real network. And remember, this is what I was saying the red is. This is what we're still going to use, even though we need to connect to the VPN through this, is what we're doing. So that's what we're going to end up doing in a second here. We had a few timeouts, but that doesn't matter for what we're doing. Most routers and things don't send the time exceeded messages. Okay, so that's how it looks, and this is the end result of getting to the server over that network. And we have 17 milliseconds, 18 milliseconds total, and 16 hops. But what I'm going to show next is I have OpenVPN, because this was on Untangle, and we're going to connect through that. So we connect in, we have username and password authentication right now. So it's connecting back into my VPN server I set up. All right. So it connects back into that, and then this is an SSL VPN, so we're using UDP 1194 like we had said before. Now though, if I go in there and type IP, if we pause it right here, you'll see the end of the IP is different because that's the IP that's the public IP of that my VPN is sitting on, my VPN server. That's the public IP of that network. And when it's sending out to the internet, that's what the servers are seeing now as the source, not the original one on the real network I'm actually in, connecting to the VPN from. But yeah, it's a different IP address, and we're going to do some pings and trace routes again, and we'll compare some differences. So with this ping here, you'll already see that is different than the 216. The one that ends in 192.142, this one ends in 614. And this is because in this case, where my VPN server is, its network and its ISP it connects into, that server for Google is closest, so it's going to use that one instead to get to that server instead of using the closest route for the network I was on. So you'll already notice because of that, though, the round trip time is longer. There's more latency or delay in the connection. So with security, there's always trade-offs. You have higher security, but you have lower convenience. And in this case, the lower convenience is higher latency and lower bandwidth as a result. But With that though, that's the difference because it's actually going through the VPN server. And you'll see it really cool in the tracer out in a second. You'll see the first IP there. And we'll let this finish out before we go through what all that means. Now, these actually did respond, but okay. So the 172.16.3.1, and the reason I'm showing this one is because that's the private VPN network's IP. Okay, so it makes like an additional IP subnet just for the VPN connections. So this also means with Road Warriors, if you have multiple connections, you can configure it so you can actually talk to each other on two separate networks. You could be California, New York, and talk to each other like you're on the same layer 2 network. That's really cool. But yeah, that's one thing why they're so important to use. The thing I want you to understand though, it's going through the real network to get to the VPN server here and hitting this IP. That's on the VPN server, the 172.16.3.1. Once it hits that, it actually gets routed out the WAN connection in the network the VPN is in, and then it goes through the hops of that provider, the routers of that provider, and gets to Google from the network's perspective of the VPN. So that's why it has higher latency, because it has more routers to go through to get to the server. But as a trade-off for that is an advantage, I have the encryption and the integrity. But that's why this is so good to have. And also, you may hear the term SSH server and SSH tunneling. That's actually very similar. It provides the same thing. And this one here is these are some IPs on that network, and just showing that you can ping them, and it's only one hop away because it's logically one hop away. It's hitting the VPN server and then going into the machine here, that host on the network. They only think they're one hop away from each other, even though they're not, as you can see from the trace route. But that's the really awesome thing, because we're on the VPN network, on the VPN server, and then going right into one of the networks behind the VPN server. But that is the cool thing about them. But with that, though, that's the basics of VPNs and a little bit of why you use them and how it looks like when you use them. So with all that, I'm Tyler with T-Tech. I do hope you enjoyed this video, and have a nice day.